In this lesson, we will learn what an explicit formula is, how to find an explicit formula given a sequence, and how to use an explicit formula to calculate any term of a sequence. An explicit formula calculates the nth term explicitly or directly by substituting a value for n. Remember that n is simply the term number that we want to generate. So if we want to find the third term of a sequence, all we would have to do is let n equal 3 for the third term to find out what that term number is. The way that we've defined this sequence, we're given the value of the term in a table. What we want to do is find out how we could express these term values using a formula, specifically an explicit formula. Since we're trying to generate terms, we're trying to generate t sub n's because that's what we use to represent this term, or this sequence, terms in the sequence. So let's go ahead and see how we could do that. If we wanted to generate any t sub n based on what the value of n is, how could we do this? The logic you have to think of here is, what do you do to 1 to get 4? Well, there's a couple things you could do. You could multiply 1 by 4 to get 4. You could add 3 to 1 to get 4. And there are various other things you could do as well to get from 1 to 4. Those two are the most basic at this point, so let's see if we can use one of those strategies. Let's try adding 1 to 3 to get 4. Let's see if that works for any others. If that was the rule that we were following to generate each term from the term number, then we'd have to use that on 2 as well, the second term. If the rule was to add 3, I'd need to add 3 to 2, which would give me 5. That is not the term that we're looking for, though, so the rule is not to add 3. Let's try the next obvious answer. Let's try multiplying by 4, because 1 times 4 is 4. Let's see if that works for the second term. 2 times 4 is 8, and sure enough, that is what the term should have been. Let's check the third term. 3 times 4 is 12, and sure enough, that's what it should be. And you can check all the way across. 4 times 4 is 16, 5 times 4 is 20, and 6 times 4 is 24. So it appears that each term is generated by multiplying the term number by 4. If the term number is represented by the variable n, what we're doing is we're multiplying that n value by 4. So to generate any term t sub n, these terms are called t sub n, we can take 4 and multiply it by n, which is the term number. This would allow us to now work backwards. If we wanted to generate the first term, which we denote t sub 1, this means the term in the sequence, and the subscript tells us which term we're looking for. The first term can be found by taking 4 times n, and since n is the subscript here, this n is the subscript, and here the subscript is 1. So what I'm going to do is I'm going to plug in 1 for n. So t sub 1 equals 4 times, and then I'm plugging in 1 for n since I'm generating the first term. T sub 1 equals 4 times 1 is 4. I can generate as many terms as I want this way. And the nice thing about an explicit formula for a sequence is that we can generate any term in the sequence. Using this rule, t sub n equals 4n, I could generate the 100th term or the 1000th term. Any term that I want to find, I can find directly. That's what explicit means. Explicit is a synonym here for direct. We can find these terms directly. You'll find another way that we can represent sequences is using recursive formulas. And with a recursive formula, you have to generate each term in order. You can't go directly to the 100th term. So this is one advantage of an explicit formula. Let's see how that could be used. Let's go ahead and jump right to the 5th term. And let's generate the 5th term here. I'm going to again use this formula, 4 times n, where in this case n is equal to 5. So I'm going to substitute 5 in for n, and 4 times 5 is 20. So the fifth term is 20, which is exactly what our chart tells us. The fifth term of the sequence is 20. Now let's go ahead and work backwards, or work in another way, I guess. What we want to do is calculate the first 3 terms of this sequence, and this is often what you'll be asked to do. You'll be given an explicit formula for a sequence, and you will be asked to calculate a certain number of terms. All you have to do is know which terms you're after. Here we're looking for the first 3 terms. That means term 1, term 2, and term 3. So let's do this. Here, the term is represented by the variable a. It doesn't matter what variable we use, but in the last example, we were using the variable t to represent our term. So all of our terms had t sub n's, like t sub 1 or t sub 5. Here, the variable is a. So if I want to calculate the first term, I'll have to calculate a sub 1. If I want to calculate the second term, I'll have to calculate a sub 2. And if I want to calculate the third term, I'll have to calculate a sub 3. The formula is 3 to the nth power. Remember, n just represents the term number you're trying to generate. So if we're trying to generate the first term, that is our n value. So I'll plug in 1 for n. So a sub 1 equals 3 to the first power, substituting the subscript, the first term, into that explicit formula. And 3 to the first power is 3. To generate the second term, I'll use the same formula, 3 to the nth power. So a sub 2 equals 3, and in this case, we're not generating a sub 3. Here we're generating a sub 2. We're looking for the second term. The second term can be found by taking 3 to the nth power. Here, the term we're after is the second term, so that is n. 3 to the second power. And remember that 3 squared means 3 times 3, which is 9. And to generate the third term, a sub 3, we'll use the exact same formula. 3 to the nth power is how we generate each term. So the third term, a sub 3, is 3, and since we're after the third term, the exponent here is 3. 3 cubed means 3 times 3 times 3, which is 27. So the third term, and you can read this the third term, or you can read it a sub 3, is 27. So we've now calculated the first 3 terms of the sequence. The first term is 3, the second term is 9, and the third term is 27. You might also be asked in problems to calculate the 50th term or the 100th term, and all you have to do is, instead of just counting a sub 1, a sub 2, a sub 3, you can jump directly to a sub whatever term that they ask you. And we saw an example of that over here when we calculated the 5th term. Remember, the advantage of an explicit formula is that you can calculate any term right off the bat by directly substituting in a value for n.